Good day, viewers. So, welcome to another edition of Namssn Tutorial. So, this is MAT 233 Mathematical Method 1. So, in our last video, we talked about how to solve differential equation using direct integration and by variable separable. So, today, we want to look about how to use homogeneous equation. So, homogeneous equation is y equals to vx. So, let's take for example, we're asked to solve dy dx is equals to 3y squared plus 2xy all over 2xy plus x squared. So look at this differential equation. Well, it will be very hard for me to separate x to one side and y to one side because this algebraic equation is combination of x and y. So what we are going to do is by using a substitution y equals to vs. So solution, I will say let y to be equals to vs. It means that anywhere I see y in this equation, I will change it to vs. So if y equals to vs, so this derivative of y with respect to x will also change. So if y equals to vs, if I differentiate from here now, dy dx, if I want to differentiate v and x are two different functions. So I'll use a product rule. So if I want to differentiate this, I'll write the first one, I'll differentiate the other one. That's like v du plus u dv. So we all know that. Plus I'll write x, I'll differentiate v. If I differentiate v, that's dv ds. So this substitution is what I'm going to use in solving this question. So if I now substitute y as vs into my differential equation, and what I have on the left hand side there is this. So dy dx is v plus x dv dx. So it will now be v plus x dv dx is equals to 3y squared, that's 3 bracket vx all squared, plus 2xy, so that's 2x bracket vx all over 2xy 2x bracket vs plus x squared. So you observe that the equation has been transformed from y to v and x now. So we then substitute and then we evaluate the rest of variables that we have. So this one will be v plus x dv dx is equals to 3vx all squared. That will be 3v squared x squared plus 2xvs. This one will be 2vx squared all over 2xvs squared plus x squared. So after that, you observe that x square are common to the numerator and denominator. So if I factorize x square out, I will have x squared. From here, it will be 3v squared plus 2v divided by factorizing x square as well, x square into 2v plus 1. X square will cancel x square. So it's equals to v plus x dv over dx. So the next thing is to collect like term. So if I collect like term, I will have x dv dx is equals to 3v squared plus 2v divided by 2v plus 1. If I move this v to the other side now, I will have minus v here. So you simplify this as a simple fraction. So we are going to have x dv dx is equals to, so you have your LCM to be 2v plus 1, 2v plus 1 and 2v plus 1, 1 times all this. So this one will be 3v squared plus 2v, 1 in 2v plus 1, 2v plus 1 times v, that's minus v times 2v plus 1. So if you simplify that, we are going to have 3v squared plus 2v minus 2v squared minus v divided by 2v plus 1 is equals to x dv dx. So we are having x dv dx is equals to, or 3v squared minus v squared, that's v squared, 2v minus v, that's v, all over 2v plus 1. So from here now, we now borrow from the idea of a variable separable. So if I separate the variable here now by saying cross multiply. So if I cross multiply, I'm going to have x times 2v plus 1 dv equals to v squared plus v dx. So by that, v is here, dv is here. So I will now divide both sides by v squared plus v. So if I divide both sides by v squared plus v, I'm going to have 2v plus 1 all over v squared plus v dv is equals to dx divided by x. So the variable has been separated. So after separating variable, you remember, so then we'll integrate both sides with respect to the variables in each side. So how will I integrate v square plus v, 2v plus 1 over v square plus v? You know that if I have a function in denominator and the derivative of that function is at numerator. So if I say, okay, this is v square plus v, if I differentiate v square, that's 2v. If I differentiate v, that's 1. So this one will just give me ln v square plus v. And derivative of, sorry, the integral of 1 over x is ln x plus c. So recall that, and that's all. So from here now, y equals to vs. Say recall that y equals to vx. So v will be y over x. You just substitute v to be y over x back into your solution. So our final solution will be ln y squared over x squared, because this is v squared, plus v plus y over x is equals to ln x plus c. So this is how our solution will be. So the next aspect is linear equation. So if you remember from elementary math that if I want to express equation of a straight line, is always in form of y equals to mx plus c, where m is the gradient. So the linear differential equation is in form of dy dx plus p of xy equals to q. So dy dx plus p of xy equals to q, where p is a function of x, where p is a function of x or a constant. So what are the algorithm of solving linear differential equation? The first thing is that our equation has to be in this form first. The first thing is to first write the equation in form of dy dx plus py equals to q. Then we find the integrating factor. So method of solving. So number one, so we recognize the differential equation has to be in this form. So the equation must be in form of dy dx plus p of xy equals to q. The second method is the second step is we integrate p of s. We integrate p of x with respect to x. Then the third step is that we find the integrating factor. Find integrating factor. Integrating factor. And what is integrating factor? Integrating factor is exponential integral of p of x. That is whatever we get here in this second step, we take the exponential of it. So exponential integral of p of x. Then the final solution, is y multiplied by this integrating factor is equals to integral of the other one, integral of q multiplied by integrating factor dx. So this is the final solution. Y times integrating factor equals to integral of q times integrating factor. So let's check some examples. So let's solve dy dx plus 1 over xy equals to x cubed minus 3. So dy dx plus 1 over xy equals to x cubed minus 3. So you observe that, oh, this is dy dx, the first part. This is p of x, a function of x. So my p of x here is 1 over x times y is equals to q. Q is the last part, x cubed minus 3. And if I follow the step that I'm going to take, well, I've already recognized the equation as linear equation, and then the next thing is that I will integrate p of x. So I'll say solution now. My p of x is this 1 over x. Then I will integrate p of x with respect to x. That's integral of 1 over x, which is ln x Integral of 1 over x is ln x. Then the third step is that I'll find the integrating factor. So integrating factor is equals to e raised to power integral p of s. So e raised to power, the integral of p of s is ln x, right? I'll now take e raised to power ln x. So e raised to power ln, e is the logarithm, sorry, e is the anti-logarithm, ln is the natural logarithm. Two of them will cancel out. So I'm going to have x. So my integrating factor is x. So that is third step. Then the final solution is y times integrating factor. So the final solution will be y times integrating factor. What is integrating factor? Y times x. So is equals to integral of q. Where is q? Everything that is here. Integral of x cubed minus 3 times integrating factor. What is integrating factor? Times x dx. So y times x, that's xy, equals to integral of x cubed times x, x raised to power 4, 3 times x, 3x dx. So xy, if I integrate x raised to power 4, that's x5 over 5, integrate 3x, that's 3x squared over 2 plus c. So as simple as that. So that is how we solve linear equation. Now, so the next aspect of differential equation is non-linear equation. So it is also known as a Bernoulli equation. So how does it goes? So it's just like the advanced version of a linear equation. So the non-linear equation is in form of dy dx plus p of xy equals to qy raised to power n. So unlike the other one is dy dx plus p of x equals to q. But the non-linear is dy dx plus p of x equals to qy raised to power n. So how do we solve non-linear equation? The first thing is that the equation has to be in this form. Then we divide through by this value. So we divide through by the last thing that is here, by y raised to power n. So if I divide through by y raised to power n, this side I'm going to have a dy dx. I'm supposed to say over y raised to power n, but instead of putting another fraction here, so I'll just put y minus n. Y minus n is like 1 over y raised to power n. Good. So plus p of x, this is y. I want to divide by y raised to power n. It means that I want to do y1 divided by yn. And you know from indices, x raised to power a divided by x raised to power b, that's x raised to power a minus b. So this one will be y raised to power 1 minus n. And if I divide this side by n, it will remain only q. So after that, I will now assume that let z equals to this part. Let z equals to y raised to power 1 minus n. Then I'll differentiate both sides with respect to x. So dz dx is equals to, if I differentiate, if you remember implicit differentiation, if you are differentiating y, you put the y dx in front of it. So if I differentiate y raised to power 1 minus n, it will be 1 minus n, y raised to power, I'll subtract 1 minus n. Then this one will have the y dx because I'm differentiating an implicit function. Okay, so let's say this is equation 1, for example. To make the equation 1 look like what I'm doing here, I will now say multiply equation 1 by 1 minus n. It means that this part, I have y minus n dy dx, but my dz dx is 1 minus n y minus n. So I still need 1 minus n here. So that is why I'll multiply this equation 1 by 1 minus n. So by doing that, I'm going to have 1 minus n dy dx plus 1 minus n p of x y raised to power 1 minus n equals to q times 1 minus n. So 1 minus n is just a constant. So now from here now, 1 minus n dy dx is this. So we're having 1 minus n y minus n here. So everything here now, 1 minus n y minus n dy dx is this. is this. So I'll just change this part to dz dx. So everything here now is now dz dx plus 1 minus n p of x. Y raised by 1 minus n is what? Is z, is equals to q into 1 minus n. So in that case, we have successfully transformed a non-linear equation to a linear equation. So from here now, we just solve this, or we solve from here using our linear equation by taking p of s and looking for the integrating factor. So let's check one example here. Example, solve 3 dy dx plus 3y over x is equals to 2x raised to power 4 y raised to power 4. 3 dy dx plus 3y over x is equals to 2x for y4. So the first thing is that compare this equation to what I have here as the standard equation of non-linear. So qy, this is dy dx. Well, this 3 doesn't really matter. P of x is this function of x times y, and q is this, and y raised by n. So solution now, we divide through. We divide through by what? By y raised by 4, because y raised by n that is here. So if I divide this one by y raised by 4, I will have 3y minus 4 dy dx. 3y minus 4 dy dx. And for this part, I have 3y. I want to divide by y raised by 4. It means that y raised by 1 minus 4, y raised by minus 3. So this one will be 3 over x y minus 3 is equals to, divide by y raised by 4. This one will be 2x4. Good. So after that, we now say let z equals to what? From here now, after I've gotten to this end, y raised by 1 minus n, I now assume that let z equals to this y raised by 1 minus n. From here now, I'll assume that let z equals to y minus 3. That is, if I differentiate both sides, dz dx, if I differentiate y minus 3, that will be minus 3y minus 4 dy dx. Why putting dy dx is because I'm differentiating an implicit function. So from here now, let's say this is equation 1, for example. I have 3y minus 4, but my dz dx is minus 3y minus 4. What is missing here? Minus sign is missing. So if I just say multiply, if I multiply equation 1 by minus 1, so if I multiply equation 1 by minus 1, so it will change to, multiply this one by minus 1, we have minus 3y minus 4 dy dx. If I multiply this one by minus 1, this plus will change to minus 3 over x y minus 3. Multiply this one by minus, that's minus 2x4. So from here now, we've gotten what we need, minus 3y minus 4, minus 3y minus 4. So everything here now is now dz over dx, because dz dx is this, minus 3 over x, y minus 3 is z, is equals to minus 2x4. So this is now a linear equation. Don't forget our linear equation is dy dx plus p of xy. So this is now a, let me call it a linear equation. And then how do we solve linear? So this is my p of x. P of x is minus 3 over x. Then I'll integrate p of x with respect to s. So if I integrate p of x with respect to s, it means I'm integrating minus 3 over s. That's minus 3 ln x. So minus 3 ln x. And you know from properties of logarithm that if a logarithm has power, the power can turn to coefficient. So my integral of p of x will just be ln x minus 3. If I bring this minus 3 to this part. So after doing that, the next thing is to obtain the integrating factor. So integrating factor, as I said earlier, is the exponent of whatever I got here. Whatever I got here. So exponential ln x minus 3. And you know that e and ln, they are anti of each other. So ln and e will cancel out. So we are going to have x minus 3. So our integrating factor is x minus 3. So after getting the integrating factor, Don't forget, we are solving from here. We are solving from here. We are solving this linear equation. We started from here. We transform non-linear to linear. From here now, we are having integrating factor as x minus 3. So the solution is here we are solving z with respect to s. So instead of saying y times integrating factor, we say z times integrating factor equals to integral of q. This is our q. Integral of minus 2x4 times integrating factor x minus 3 dx. So zx minus 3. So x4 x minus 3. That's x dx. So if I integrate x, that's x squared over 2. 2 cancel 2 plus c. Zx minus 3 is equals to minus x squared plus c. And this is our final solution. So we now recall, where are we starting from? Z equals to y minus 3. So recall that z equals to y minus 3. This one will be y minus 3, x minus 3 equals to minus x squared plus c. So this is how we solve a non-linear equation. So from the beginning, we started from method of homogeneous equation, y equals to vs. So all differential equations, they have their own unique way of solving them. So this one now, you can't use homogeneous. You can't say let y equals to vs. So you struck at somewhere. So it is better to first analyze it. Oh, what does it look like? Okay, this one looks like a linear equation, but because of y that is here now, it makes it to be non-linear. So this is how we solve a non-linear equation. You can pause the video and go back again. So thank you and have a nice day.